So my name's Anne, and I am part of the Force 12 IO project, which is a budding open source container experimentation project. And you can tweet us at Force 12 IO. Yes, we've had some excellent talks today, some really, really good talks. And I was looking into what makes a good talk. So I was looking up Dale Carnegie, the author of How to Win Friends and Influence People, says that if you give a talk, the key to a successful talk is you talk about what you know and what you're really passionate about. And in our team at the moment, we're really passionate about two things. The first is containers, and who wouldn't be passionate about containers? They're extraordinarily interesting. The second is Game of Thrones, and I miss it so much already. And what we realised was there are actually quite a lot of similarities between the competition for the Iron Throne in the world of Westeros and the competition for who's going to be sitting on the bare metal in DevOps, in data centers around the world in the next 6 to 12 months. And those similarities aren't even that contrived. So yes, that will be what we're talking about. Who will be sitting on the Iron Throne there? But I'm not going to, this talk is not going to be full of an awful lot of details about what we've done, because that makes for a very boring presentation usually, but there are an awful lot of details that you can look at. We've written a blog post with a bit of background on the projects, and also an awful lot of detail about what we've done with containers, how you can try it out yourself, how you can have a play around with what we've done, and that's at force12io/docslawn if you're interested in the detail. So VM versus container. So back to my stretched analogy. Now, obviously, we're all very familiar with the strengths and weaknesses of the various contenders for bare metal. And firstly, bare metal, of course, we all know that its main strength is power, but its main weakness is in flexibility, which does lead to not amazing server density, and that's why we've moved away from it. And if anybody can think of a good analogy, Game of Thrones analogy for server density, I would be extremely happy to hear about it. I can't think of one. Come and tell me afterwards. So bare metal, yeah, absolutely powerful, but not very flexible, and that means that you're not necessarily always using your capacity as optimally as possible. So then came along VMs, obviously. Everybody loves a VM. And the strength of the VM is it is massively flexible, and it is completely agnostic about where it's running. It doesn't care who's hosting it. It'll make do with wherever it's running. And that has led to enormous server density and good utilization of resources, which has been fantastic. Other strengths of VMs, obviously, they're very security aware. They understand how to keep your data secure, and they're very good at networking. They support networks extremely effectively. But what are their weaknesses? Well, they are slightly overweight. They are a little bit weightier than they potentially could be. We know that there is an awful lot of overlap when you're running a guest on a host between what the guest is doing and what the host is doing, which means that you're not getting the optimal use of the capacity that you've got in your systems. Then we look at the new kid on the block, containers, who've come in, and they are not overweight at all. They are super lightweight operators, and they also, unlike VMs, and VMs are incredibly fast-moving compared to bare metal. You can have a new container up and instantiated inside 4 or 5 minutes, which is amazing. But compared to the speed of containers, that is ridiculously slow. Containers. Well, we hear an awful lot about the speed of container instantiation, and that's what I'll be talking about this evening. But we're talking about at least 100 times faster than VMs. Possibly, you hear talk about 1,000 times faster. You hear talk about even about 10,000 times faster. But one of the things we'll be looking at this evening is what's real there. What can you actually achieve? But there are also massive weaknesses and drawbacks to containers. They are unseasoned. They are new technology. They really are new technology. Security, there are definitely issues there. They are a little bit trusting. You won't necessarily want to be running them in every possible environment. And their networking is not, as Craig mentioned, the networking is not quite supporting their power and their potential at the moment. So containers, and one of the most interesting, I think the most interesting thing about containers is their speed, the speed of instantiation, and that could completely change the way that DevOps works, the way that we architect, the way that we run systems in the future. And it already is at Google, but could it be elsewhere? And really, we hear, I'm sure you've all heard that a container can be brought up fast enough to process a single network packet. Well, that is pretty bloody fast. Is it true? Is that actually fact, or is it just pure fantasy? Or is it something that you can only achieve with ridiculous resources or money that might only be available, say, to Google, or amazing Google brains like Craig's, and therefore isn't really available to us right now. So it's not fantasy, but as far as we're concerned, as far as us ordinary Joes are concerned, it's still science fiction. So the question is it? Because if it isn't, then if it really is possible to instantiate containers within seconds, then that leads to a completely different way, potentially, of approaching how you might be scaling your systems, using your capacity in the future. Now, we've already got autoscaling. We love autoscaling. Autoscaling is great. But it's not, by any stretch of the imagination, perfect. 4 minutes to bring up a VM, that's great. That's amazing compared to 10 years ago. That's utterly amazing compared to longer ago than that. But that's still not fast enough to respond real time to demand in your network, which means you have to provision early, and then you have to keep your servers there for longer than they really need to be. It's not as efficient. It is wasteful. And I really hate spending money, and therefore I want it to be cheaper. I want to only bring up my resources when I need them. But with containers, it opens up the field to doing something completely different, which is actually something that Google are doing internally, which is, and they don't have a name for it, but we've given a name to it so that we can distinguish ourselves between autoscaling, which is bringing in new capacity, and microscaling, which is using your existing capacity in real time more effectively to handle your real-time current demand. This is what containers makes us think about. It's what if rather than bring on a new server, we just say, well, actually, within our microservice architecture, we have some services that should be responding to this new demand, and some services that are not that dependent on this new demand. But why don't we kill off those services and fire up more of these demand-dependent services? And then when the demand drops back in real time, then when the demand drops back, we can kill off some of these new services we've started and start the less demand-dependent services again to catch up with the work that wasn't being done. So instead of auto-scaling, instead of adding capacity, we're using the capacity we already have more effectively in real time. Now, there are analogies for this in the networking world. Networks already make real-time decisions about quality of service because they have a fixed capacity. Going through going through your network, you can't put in extra wires, you can't put in extra routers in real time. But it makes real-time decisions about what packets are prioritized. Could we use the same thinking that goes into that on our physical infrastructure? And we absolutely had no idea. We just had no idea whether we could do this or not, and whether it would be useful. And we realized that there were 4 things that would be utterly key to whether or not this was a plausible idea or just a totally crazy off-the-wall idea. The first is that you'd actually need to be able to have multiple services within your infrastructure that had different demand requirements. So maybe you had web services and maybe you had batch services that were running, and that the demand for those was not correlated together. If you have a single monolithic architecture and all of your services look identical and they all respond to exactly the same demand, then you get no benefit from this because all you can do to scale up is add extra capacity. There's no point in moving things around or shutting some stuff up and beefing other stuff up. The other thing we'd need is fast container instantiation. Containers, you'd have to be able to shut down containers and fire up containers inside seconds for this to really work. You'd need a cattle not pets approach. You'd actually need to be able to kill some of your services off, bring up other services instantly, otherwise you wouldn't get any benefit from this. And the final thing we were looking for was we didn't want to have to go to heroic measures to make this work. Because if we do, then we're kind of in the realms of science fiction. We want to know if we can do it as ordinary Joes. Is this plausible to do on infrastructure that's available now to everybody at a reasonable price? So no progress without experimentation. So we thought, well, we'll build a demo and see. We'll see if we can verify each of these things. Here is the demo. Now, this is our live system running on ECS, or it should be, if I can. No or not? No, that didn't work. Let me click on the link on that presentation. Don't click. Right, okay, right. Okay, go. Right. Right, so this is a live demo. So we wanted to find out, so we built it live to find out. Yes, excellent. So what we built was a system that we used to replicate the question that we were trying to ask, which is, in its most basic form, how quickly can you instantiate containers on normal infrastructure repeatedly and reliably? So we built it on ECS, which is basically what we chose to be our utterly ordinary Joe environment for building our demo system. And what we did was we set up the most simple system imaginable, which was three container instances on AWS. So effectively 3 nodes. Each one could support up to 4 containers. There we go. I'll move this down. There we go. That's better. And what you can see here is live what's going on ECS on our cluster at the moment. So down here, you've got our 3 container instances and the containers that are running on them. Above, you can see what containers are started and stopped on the system. Now, we defined 2 container types. A container type priority 1, which we defined as being demand dependent, and a container type priority 2, which we defined as being effectively demand independent. What we wanted to, and then we created another container that generated random demand. So it was simulating demand. We decided we'd keep it as simple as possible by just simulating the demand. So red is our simulated demand. The simulated demand is for priority 1 containers. So what we wanted to achieve was that, and we wrote the Force 12, it's a scheduler, but it sits on top of, it would sit on top of the ECS scheduler, or on top of Marathon, or on top of Swarm, or on top of Kubernetes. It's not really a scheduler, it's more of a kind of a demand scheduler. And its job is to look and see what demand is, which is currently the red line, and say, okay, in that case, I want to start priority 1 containers to match that demand, and I would switch off priority 2 containers to make sure there's enough room for priority 1 containers. And then as the demand drops, and I've suddenly got more space, it wants to use up that space. Now you're seeing a bug in ECS that, oh no, that's caught up again, which I'll talk you through. It wins if number of priority 1 containers meets the demand, and the number of priority 2 containers tops it up to be the complete capacity of your system. So we're looking at matching demand and utilizing the system as optimally as possible. Now, what you're seeing here is a bug, a workaround that we had to put in. It turns out that doing this kind of thing really does push ECS to its limits. And what we had to do, we found that about every 6 minutes on each container instance, the ECS agent will fall over. So our workaround for that, Amazon have been very helpful, and they are helping us, and they do have a bug fix which is currently being reviewed for that particular problem. But our workaround was to effectively freeze our demand for a minute, every 5 minutes, to give the ECS agent time to recover so it doesn't fall over. But that's kind of an interesting example of where container technology is to a certain extent. I wouldn't consider this to be ridiculously stressful, but it is pushing at the limits of what ECS will currently do. That's one of our. Looks like one of our container instances has fallen over there. Never mind. It's coming back. Yes. So. What did this tell us? Well, this told us that actually it's not total fantasy that containers could potentially match your demand in plausibly close to real time, because we haven't done the optimization here at all. We did a tiny bit, and I can talk about that to folk afterwards if you want to hear about it. But fundamentally, this is straight out of the box ECS with really nothing heroic done to it. And containers can be brought up and instantiated to match demand within about 4 seconds. And that's not crazy. I mean, that is still 100 times better than you can achieve with a VM. So I think we considered this as potentially proving the case for microscaling. It is plausible. Now I'm going to have to turn this off and go back to the... Put my specs on, then I can see broadly what I'm doing. Now I've absolutely no idea where this middle tab. Yes. Yes, here it is, sorry. No. Excellent, thank you very much. Right, I can skip over my canned presentation for if we didn't have any wireless connectivity. And my screenshot for even if that failed. Okay, so did we manage to do that? Yes, with no heroic measures, we're talking about 100 times VM instantiation speeds. So really, this is something that you should be thinking about. This is a new world. This is a way of doing things very differently on your infrastructure from the way that we're doing it at the moment. So our conclusion was that microscaling, scaling up and down within your existing capacity, either while you're waiting for new capacity to come online, in that 4 minutes, that in a year's time will seem like a century, now seems very quick, but 4 minutes is a long time. Within that time, you could be microscaling. You could be scaling using containers within your existing infrastructure to help you cope with peaks in demand. And so, yeah, we think this is, Google are already doing it. And we think that it is plausible for everybody else to be starting to think in those terms. The big question, are containers ready for production? Yeah, we've hit some problems with containers in production, even on our demo there. I think, yes, they are ready for production, but not without expertise. But now is the time for your team to be getting that expertise. They need to be thinking about it, because it's a completely different way of thinking about your infrastructure. Yes, some spoilers for Force 12 IO Season 2. It will be racier. We're intending to run on bare metal, Mesos, Marathon, open source, possibly Kubernetes. But we want to see whether or not we can get that 4 seconds down to 1 second, or even lower than 1 second. And we will be open sourcing at some point when we tidy the code up. And the code is written in Go for much the same reasons that Craig laid out. And you know, much of my youth was spent writing C, and I find Go quite a good language, and it's a nice language to work in. It stops you from makes you less inclined to reinvent the wheel than potentially C or C++ does. So who do I think will be sitting on the bare metal in a year's time? Well, the strengths and weaknesses are still there. At Google, they're running containers within VMs within containers in order, and that's not just pointless machoism. That is actually to try and balance off the strengths and weaknesses of all of them, because they all do have those security, networking, strengths and weaknesses going for them. Right, okay. Yes, at some point I should ask you what you're doing internally. So yes, at the moment it looks like they'll probably end up all working together, which is interesting. And of course, there's the convergence that's definitely happening between containers becoming a little bit more heavyweight as they start to add in the security, the networking, and VMs becoming more lightweight as they start to strip down and duplicate less of what the host is doing. But in the end, the only thing that we can all be certain about is containers are coming, and it's time, I think, now for your development and ops teams to start getting used to them, familiarizing themselves with them. So that's the end. I think if we have any questions, probably over pizza again, or unless it's time.
Thanks.